It is insane, absolutely insane. Thank you, Agla. Thank you, Roberta. Thank you, Ramila, Harrison, Heather, Sasha, Mike Blackhat, Brams, Taupe, Mr. Load, YT, and Harrell, Kenneth, and all the other folks joining from our TikTok live side. Hi, Vicky. Hi, Bill Fran. Thank you so much for being here. As you guys all know, Crash Course is our bootcamp series that is designed to help you learn how to be a visual scripting master in just 3 weeks. We're going to give you the skills, the knowledge, the tools so that you can create an amazing interactive effect. Today with me, I have your beloved and everyone's beloved, August.
Hey everyone.
Hi, August. How are you
It's
feeling? Happy Monday.
great. Happy Monday.
I see so many people in the chat, even though it's Monday morning for you guys. Thank you for saying hello, Celine. Hello, Build Fan. Cute Alice says, I'm here. The energy in the chat is absolutely insane. I can't wait to see what we'll learn today. Speaking of August, maybe a lot of the people here are seeing you for the first time. Can you give a little self intro?
Yeah, so my name is August. I've been an interactive engineer at TikTok for a little over 4 years, which means that I work between the engineering and design side and do a little bit of both, kind of like a indie game developer position.
Okay. So you've been here for 4+ years. You must have seen the progression of Effect House from when we were a private app to private beta to public beta and now public for everyone. How do you feel in the journey? Is there anything that changed that you're like, this is incredible?
Uh, yeah, definitely when they started adding physics,
Oh
I feel like
yeah.
stuff started popping off once we got material graph, material editor, so we could kind of make our own shaders, like each of these things. And there's so many other things to name. Getting arrays in visual scripting was the biggest thing in my opinion.
Yes.
Uh, but there's like so many individual steps where it felt like we were taking the entire community and everybody was just leveling up all at once.
Uh-huh. And I think it's absolutely incredible the speed that we're growing, adding new features, and people like putting feature recommendation request on our forums and it coming to life. That's just insane to me how we were able to grow this tool into a major platform that everybody uses now. And you see so many awesome TikTok effects that have gone viral over the years. And I know the person behind them and I know their journey. So being with them in that process was just absolutely so rewarding for me. Okay, can you tell us a little bit more about today's session? It is named Subgraph Secrets. Yes, we love repeating sounds, Subgraph Secrets. If you guys don't know, tomorrow's lesson is Versatile Variables, and I'm quite proud of the naming. So tell me more about the session. What is Subgraphs?
Well, in TikTok Effect House, we use visual scripting for all of the logic that happens in Effect House. So with visual scripting, there are a lot of ways to like kind of make it work faster or make it look more neat and tidy. But subgraphs are sort of like a little capsule that you can put a bunch of logic in with some inputs and outputs to kind of like compartmentalize some of your logic, make it look tidier. There are a bunch of reasons for why you would use it, and I'm going to show you how to use it and why you would want to use it and give you some ideas for the future.
That sounds so good. Speaking of, let's go look at the agenda. This is the agenda for the day. What is a subgraph? Logic subgraph, screen to pixel, random number supreme and automation, bool state, and input output. Ooh, it seems like we have an exciting day ahead of us. But let's hear a little specific about these courses. You guys all know that we have been crafting an amazing video resource for you guys. It was all of last week, and we released 6 videos. So if you okay, all should be good.
Okay. Should I, is everything Should I start from somewhere else, or should I continue?
Yeah, I think you could start from maybe like 1 minute, 30 seconds back.
Okay, a little bit back. Okay, so yeah, I guess I was mostly just talking about the inputs and the outputs because that's all a subgraph really is containing the logic into this infinitely small space where you just have inputs and outputs, and something happens in between. So the outputs, like on randomized finish, would be a great thing to have if you don't want to go inside of this subgraph, but you want to know when the randomizer ended. So you can just hook up any other logic, maybe a whole nother subgraph to this to do something else when the randomizer finishes, and the index will tell you which item it landed on. So if we dive into the randomizer, you can see it is pretty crazy just because you have to zoom in to kind of go step by step through all of the stages. We put a lot of these comment boxes in to tell you what's happening in these sections so that if you did want to dive into this subgraph, you could. Oh no, getting the rainbow. But let's find another reason to use a subgraph, something that might be helpful in other cases other than presenting the whole project. This project only has a few of these input parameters that we're saving to variables. And we're doing this because, as you can see, there are these white lines over here that are just kind of going all across the whole project. And having less of those makes it look tidier. So for these variables, so that we can reuse them, as you can see, tap to spin is right here. So we save it into one variable and output it on the other. For instance, if I put tap to spin and I just add something to the name, like a space for each of these, then if I come back, I think start, we would just change to set. And then we look at the outside of it, and now we can see all of our variable names. This is really helpful. And now this whole chunk for much larger projects, that could be like 25 different variables that you're setting. So this would be really nice when you have more and more. So you could basically do that with all of these comment boxes. You could kind of take as a chunk of logic, maybe add some of the other values here. Like maybe I would include this if with these, and you could kind of organize it into just a series of subgraphs if you want. And that would make it much easier to read, because instead of reading a bunch of comment boxes and sections of nodes, you would just be reading variable initialization goes into this next stage, goes into this next stage. Part of the reason why we left randomize more free on the inside of the subgraph is because we consider it one of the first templates that most users use. And so this might be something where they can look through the nodes and kind of get an understanding of how some of these nodes work together. And so this is kind of like a learning first initial visual scripting kind of exposure. So we wanted to leave some of these classic configurations out in the open. Okay, let's see. Let's go to some of the other subgraphs that I have in mind. Let us, let's take a look at this. So this is randomizer. So actually, these images that you're seeing are 3D images. So they do look like 2D images, but they're on 3D transforms, and they're on basically 3D image, which is essentially more of a plane. And if we take a look at this look at node component, and we remove that on these, you'll see that when you turn your head, it moves with them like a 3D plane. And so maybe I should keep that on so you can see me talking. So if I wanted to do something cool, I might do something similar with this just to make a point. Let's make a 2D image, and we'll add a face. Oh wait, yeah, that's all we need. Okay, so we'll set the position of this, and we'll make it the title. And we'll turn off this title, and this is our new title, okay? And in our subgraph here, we're going to switch to the title scene object. And now you'll see that because I switched the input of the randomized subgraph to this totally other object, now it will still do the same thing it was doing before, but with a different object, because that object also has an image component. So that's really cool. We're not even using the original objects from the randomizer template. Now let's do some other stuff. Maybe we can manually set it on the head. Let's get the face info node. Now this center position from the face info node, let's see if we directly plug this in. And then if we set it every single frame using the update node, update will be like update in most game engines where it just happens every single frame. It's just an event that constantly happens. So then if we set this, you might notice it's not actually moving. That title is not following my head. So here's a third reason why you might want a subgraph. Let's look up screen to pixel. You might notice this little download symbol on the right side. If I click this screen to pixel, it will download from the asset library. Just
That
to
is
make
an
my
awesome, nifty feature. I didn't know you can do that. I always went to the asset library, typed it in, downloaded, but now that I know that I can just summon it from my visual scripting page, that makes everything so much easier.
Yeah, so convenient, so convenient. Okay, actually here, I'll just go to visual scripting. So this is where it's pulling them from. So anything that exists here, if you just type it in the search, you'll find it. And the one that I was gonna pull in is the screen to pixel. So clicking this button is the same thing as double clicking it over in here, except it won't automatically insert it into your visual scripting. To do that, you can drag it directly into the visual scripting panel. And now this one has actually passed away, so that's why it's a ghost subgraph, unfortunately, but it'll act the same. No, this is our brand new, sorry, I have to make jokes sometimes, but this is our brand new instant subgraph. So I'll plug it in like I would normally, and then I'll tell you about our instant subgraphs in a moment. But just know that it functions exactly like a normal subgraph. Now, if we restart, you'll see that this follows my face. Now, why is that? It's because this face info node will give you the center position, vec2 in just normalized screen space. So if you look at finger touch, that will give you the touch position on the screen in the same format. This is a 0 to 1. So that basically means that the left side of the screen is 0 and the right side of the screen is 1. But if we set a value between 0 to 1 for the X and Y on one of these, those move through pixel space. So it'll look like it's just moving through the one pixel in the center of the screen. So if you ever need to convert from that normalized space to the pixel space that the screen transform on 2D objects uses, so this screen transform that has the 720 and 1280, that is pixel space. So you'll just plug it into this to convert. So there are plenty of times where I would convert from like mathematical kind of number space to another one. And this is the subgraph that's like probably the most commonly used, just converting from one thing to another thing, just processing some data, and it's mostly just containing math on the inside. If we take a look on the inside, you'll just see literally just math. just some add and multiply. It's actually pretty simple. So that's one way to kind of do the face attachment. And then of course you would want to offset it so that it's on top of my head, not on the bottom. But yeah, this is a 2D image instead of a 3D image. Totally changed it, totally found a different way. And we use this new subgraph. Now, let's say you wanted to do something else with this screen to pixel, like plug it into this finger touch and do something else. So inside of here, if I change anything, since this is an instant subgraph, the blue kind of subgraph here, when I change one, I'm actually changing the sort of blueprint of this subgraph. And maybe that's why it's blue like this, because it's kind of more of a blueprint that I'm editing. I'm not editing the actual one in the visual scripting, even though it looks like it. It feels like I'm editing this right here. Well, really, I'm editing the blueprint that goes to both of these. So here, I'll show you what I'm talking about.
Professor Ago coming up with all the acronyms to help us remember.
Is there an acronym? Maybe. Here, I'll just add a comment. I don't want to change this, but look, it's in both. And then we'll go out of the subgraph. First, we'll peek into the top one. Hey, there's our comment box. We'll go to the second one. Hey, there's our comment box again. And that's because we're not looking into this thing that's in the visual scripting panel. We're looking into this blueprint that we can edit, and it'll change all of these. That's so useful when you're doing something to a bunch of objects. And while you're developing, you can just keep editing it, and it'll automatically update all of them. And you can keep testing how it works with all of the objects. So yeah, that's super helpful. For screen to pixel, like imagine that for some reason you needed to change this 720 by 1280 because something with the screen size that you're working with changed. Now you can just edit it in one place and it will change on all of them. Very, very helpful. Okay, so let's talk about some cases where you maybe encounter something that you see as a problem. And maybe we can go to another template now. I think we've exhausted randomizer template. Let's take a look at Garden Guardian. It's such a great example of reusable subgraphs that you can use in all kinds of places. So I'll just open this up and we can work within this project and do some just random stuff to play around with subgraphs. Right off the bat, you can see that the one thing I said at the beginning of this live stream is not true. There is not one top level subgraph for this. And that's because this is a microjam project, which is more focused on teaching users how to use features or techniques in EffectHouse. So this project is an educational project more so than it is a template where you would just replace the assets. So if you take a look, we can just see right from the top without clicking into anything how this system of subgraphs is working together, where we have touch, drag, and drop. You're touching and dragging and dropping with this one. And then while you're dragging it, you can see this output here says drag. So while you're dragging it, we're checking this subgraph every frame to see if you're hovering over another object. So there's kind of a network of subgraphs, each doing their own part of the heavy lifting of this project.
August, I have a question. When you guys are making these templates, do you guys think of the subgraph idea first? Like, oh, okay, I think I'm going to make it into a subgraph. Or do you guys start making it, see that there is that the project uses this mechanic in multiple areas, and then be like, oh, maybe this should be a subgraph?
It really depends. It really depends on the project and how complex it is. If I can foresee that I'm about to make something that will repeat, then sometimes I'll create the subgraph even if it's incomplete, and I'll keep working with that subgraph and keep building it up. But there have been plenty of times where there's some set area of logic that just is out in its own space. And then at the end of the project, we see, this could be contained in a subgraph and maybe reused in other projects or something.
How do you decide something is subgraph worthy?
Um, it's everybody has their own opinion, really. I personally like things that are more generic, so if I see something, sometimes I'll say this by itself should not be a subgraph, but if we abstract out the type so that it could work for any object, not just the one specific type, then it becomes like more worthy of being a subgraph. And then there's also the idea of what's in the asset library maybe has a higher bar than what's in your own personal subgraph library. And I can show how to add to your personal asset or subgraph library as well.
Guys, this is actually so funny because these are our interactive engineers who's actually building these templates, right? So if you go through the templates, you can see that everyone has a little bit of a different style. And sometimes me and some other folks at TikTok, Effect House team, can see this way that the template is built and say, oh, this is probably an August project. This is probably a Melody project. And I think that is so, so, so funny.
Yeah, it's definitely, I think even more so than writing actual code, visual scripting is even more stylized, I think, because the way that the lines are so visual and the connections are so visual and everything, I think that visual aspect, like everybody has their own opinion on it. Whereas with coding, it's just like brackets on the next line or brackets on the same line. There's not too much variation in how it looks,
I
which
think
is kind of cool.
I think if a person is starting out, it might be hard for them to realize, oh, this should probably be a subgraph. For those beginner creators, do you have any advice on how to recognize what could be a subgraph or to even help brainstorm, like, hey, I think I should design this in a way that could be a subgraph?
Yeah, so I have the three strikes method where, and I use this for movies and books too. Uh, but the first time I encounter a problem that takes, a little bit of brain power or some significant amount of time, uh, that'll kind of stick with me because I'm like, okay, I didn't just breeze through this section of visual scripting. I remember kind of, it was a stopping force that slowed me down from bringing my idea to life. So the next time that I encounter that same problem, um, like I think it's just a habit you develop where you're like, oh, this is the same problem. Like recognizing that this problem is the same problem as your last problem, and or there's some sort of overlap maybe. And so when I see that, then it kind of highlights in my head, okay, this is a recurring thing that I'm spending time on. If I encounter it a third time, then I'm like, okay, I'm not going past this problem until I turn it into a subgraph because I'm probably going to encounter it again if I've already encountered it 3 times. Um, so yeah, that's really my three strikes rule. Sometimes I'll make it on the first strike if I feel like, hey, this I'll probably definitely encounter this many times. Especially if it's like screen to pixel, I think I made very, very quickly because I could just identify there's multiple different kind of like formats. There's the normalized 0 to 1 and there's the pixel space, and we use both. So that was a pretty easy one to identify. I'm going to want to go back and forth between these. Yeah.
Okay, thank you so much for the tip. Actually, we are running a poll right now on YouTube and we asked all of the audiences, "Hey, what is your favorite subgraph?" And can you guess what is winning with 41%? It is the Ogle counter. Oh my gosh.
That's still out there. Oh no.
Yeah, and in the comments, me and Joe was talking about August's template goes so hard and how I learned visual scripting with your microjams. So keep up the amazing work and please teach all of us how to make an awesome subgraph.
That sounds great. Thanks so much. Okay. So let's see. We can see a lot of these subgraphs here are actually repeating. We have basically 3 lines: the touch, drag, and drop, on hover, water can animation, snap to point. So this is a pattern. As you can see, there's the top section, the middle section, and the bottom section. And they're all doing the same thing. One has a soil animation, one has a sun animation. So they kind of each have their own things. So this is one of those questions of kind of like what Celine was saying, like, how do you know when it's time to make a subgraph? This is a great example of when you might want to deduplicate some of your code. So what I mean by deduplicate is like you have the same logic 3 times. So if you didn't have subgraph instances, like we didn't when this project was created, then if you ever change touch, drag, and drop, you would have to change it 3 times. There's a very high likelihood when you're doing things like this for human error. In programming, or in the tech world, we call human error basically any time where you're relying on a person to remember to do some task to edit the code or edit the visual scripting. And it's just very well documented and known that people will definitely mess up sometimes. And so you want to put all of that reliance that you can on the computer, basically, on the whatever's processing it. So we definitely could take these and compartmentalize them. So what we might do, and I'm not suggesting you go in and do this when you're using this template, but you'll turn this chunk into a subgraph. Create subgraph. And then it goes way up here. And then if you're going to do this, you have to notice what's different between these versions. Like you can see the first thing I did was I pulled out the soil animation because it's a totally different subgraph that's not the same amongst all 3 of these. So I didn't keep this in the subgraph, and you can see that's going to be the main difference between these 3. Now, if we wanted to, we could finish this out. Oh no, I took the comment boxes too. Well, that's fine. This is just a demo. The first thing I would do if I was kind of using this for deduplication is I would put in all of the inputs. So we have soil holder here, snap to center. We don't want to expose this one because we're not really using snap to center in this project. So if we know for our entire project we don't care about one of the inputs, we can ignore it. So we'll change this to scene object, and we'll say scene object. Oops. And so we would do this for like everything. We find this one is here. This is a global thing. This is not specific to this set of nodes for the soil. So anything that is specific to the soil, we need to find. So here are 2 transform inputs on the on hover subgraph. So this is soil holder and interaction hover zone for the soil. So we would want to plug in, I think this counts as other, because as you can see from the symbol here, it's a screen transform. So we'll just plug in this, and we'll use that method that I talked about earlier with this. So I'm not done with all of the objects, but let me show you how to choose the correct. Oh, right. That's only when it's auto-generating. So I was just going to hopefully copy these inputs. We'll just manually copy them. But now we can expose these to the outside. And then let's see, we have soil holder here again, which I think, oh, that's the scene object. And this one is, okay, yeah, using screen transform. Okay, so we'll have another one, scene object, hover object. Actually, you know what I would want to do? Maybe I'm going too far into this one, but get component by type is a great node. Oh no. Get component by type. And this is another great way to use a subgraph. So I'm seeing that I'm taking in the scene object and the screen transform of the same object. So what you can do instead is take in just this hover object scene object, and you can get the screen transform for it and plug that screen transform where we were putting that first variable. And that was the only place we were using that, so we can take it away now. And now we have the hover object scene object that we can plug in on this other end, quite a ways away. And then soil holder screen transform is used here. Again, that was that same object that we plugged into here, the soil holder screen up. I can't say this that many times. It's a hard thing to say. Okay. Transition speed. You might want to plug that to the outside, but I'm not really going to worry about it. 0.5 is fine. And then some of the things that you might want to do, as you can see, the on hover outputs some things. But from our original use case, we weren't outputting anything from these. So it depends how much you're going to reuse these. If you are going to reuse some of these outputs, then you would put them to the outside of the subgraph as well. So now we can call this, see, this is very specific. So this is not a reusable subgraph because it has a very specific set of things going on. But we'll say shelf object because it uses each of these three shelf objects. So now what you could do, and this feels scary whenever you do it, is you just delete.
That is so scary. Oh my gosh.
Don't delete until you've already proved that your new subgraph is working, though. You know, definitely. And if you're going to do something scary like that without already proving that it's going to work, definitely save a backup of your project. You know, just common sense things. Okay, so now we can just copy what we were doing to this other one. So that stay is what's going to plug in up to the apply sunlight, because this is the sunlight one. And then we'll make another one for this top object. And then for this stay, I know I'm pretty zoomed out, but I think you get the idea. I'll drag this stuff a little closer. And I definitely deleted the animation for the water accidentally. So that's why you save backups. We'll plug in this start and stop into the sun animation. And then, as you can see, our project has these three repeatable parts. Really what I should have done is on this one, just convert to subgraph instance, which I'm just going to do. And then duplicate these out. So now you have your stay here and your start and stop here. And now these are all the same. So now you can just edit one anytime you need to edit anything, and you don't have to copy all of your changes over. It's really amazing. And your inputs will all stay different for what you actually are using. So, okay, here's the health gauges. The watering can holder will be the first one. The health gauges, sun holder will be the next one, and the soil holder will be the last one. Soil holder, that's kind of hard to say. Why did I name it that? And then the hover zone, I think, is up here. So really, this hover zone is the same for all of them. So I could probably save that to some kind of variable and not put it as the input of these subgraphs. Or, depending on if this is a template that you're sharing with other people or if you're using it alone, that could just be, here's what you can do. And take a look at this. So interaction hover zone, it's there. And now, oops, if I delete this, now it's gone in all of them. Simplifies my work process. Okay, so last step, hover object. So this is the same thing. Oh, did I? Wait a second. I just remembered. The scene object is here. For the touch drag and drop. I think that's the same one, right? Hover object and scene object. Well, okay, so it's not snapping back to the point. So this scene object. I wonder, I can't remember if that's a different scene object. I think it's the same one, so we might be able to just remove the other one. So let's see. We've got a scene object used, but hover object is plugged into all of these things. Maybe I shouldn't have deleted my first one. Got to be careful to have a reference.
That's why we have backup.
Yeah, right. Okay. So, watering can. Okay, there we go. So you actually only need one. The scene object, since we used this screen transform to get the screen transform from the scene object, we only actually need this one input. So as you can see, you kind of like learn how the subgraphs work as you're working with them. And it's almost like you're taking this ball of clay and slowly working it into the final product. And hopefully, if you're doing things in a good way, you have the least number of things on the output that you need to reset every time you duplicate. Like this is, in my opinion, this is really nice because if I wanted to use like a huge array of objects, I only need to input like one little thing. And with these, there's not too much unique stuff that I need to change about them. So that's pretty nice. Okay. So that was a great example of how you can deduplicate by using the new Subgraph instances and really simplify your project down to make the big chunks of it, very reusable. This will speed up your production so much faster, especially if you can do this with something that's like actually very reusable across many projects. Okay, so one thing I wanted to share was how to export subgraphs and how to save them. So if you click Save to Node Library, this will permanently save this to your node library, shelf object. So, my typing is going so slow right now. Shelf shelf object. As you can see, now it is automatically here, super accessible. Even if I deleted this from this entire project and deleted all the stuff about it, I could open another project and just type in shelf object and it would just be there in Effect House for me. This is really great. It's as if you're uploading it to the asset library. The one thing to keep in mind about this is that it's not globally attached to your account. So if you switch computers, you'll have a different node library. It's like locally saved on your hard drive. So if you want to switch between different machines, maybe you have a PC and a Mac or something like that, you can export your subgraphs and send them to friends, send them to colleagues, send them to your grandfather for his birthday. And by that, let's see. Yes, you can go into this is called the hamburger menu, the three lines, three horizontal lines up here, my items. If you open this menu, you'll see all of your variables. If you're inside of a subgraph, you'll see your subgraph variables. And then below that, you'll see subgraphs and instance subgraphs. So in the subgraphs area, you'll see these little trash cans and download button. The download button opens up a dialog where you can save your projects or your subgraphs. So then you would save it somewhere on your hard drive, and then I'll show you for the next part how you might import. So for me, I'll open up my subgraph library, and I just have a bunch of experimental things. I have the for loop one here. I really should rename this. Oh, it's still trying to save, sorry. Subgraph library. I call this folder the for loop. But yeah, it should really be the for each loop. So what it's doing here, let's rename it right now. Iterate components of children. So if it has a list, it's going to do a loop and just output each of the items. That way you don't have to know how many items there are or anything like that. So let's just do something simple, but also you would probably never do it. So UI foreground, it just has these 4 items in it. And we're just going to do something like finger touch. Finger touch. And every time you touch, it's like on tap. When you tap, we will just do this loop. And so let's see. This is using transforms. So really it should be named like for each transform. Oops. There should be another parenthesis there, but I'm going to change it in a second. So what you would basically want to do with this subgraph is currently with subgraphs, we don't have a way to like use the drop-down menu to change what type it's working with. So if you want to change what type of object you're iterating over, you're looping through, you have to go inside of it and change it to whatever you want. Actually, for this, I actually just want the scene objects directly. So I'll kill this connection, and then I'll connect the scene object directly to the output. So now instead of transform, this is actually scene object.
August, Heather is asking, is there a way to globally save it or retrieve it if your computer dies?
No. So that's a good thing to note. And that's why I keep a actual file, all the files of my subgraphs, so that if I want to, I can like back up my really important or really hard to make subgraphs on the cloud. On the cloud, the general cloud. I'm not going to say which one. So now we've got this scene object, and we can change our for each to for each scene object. And in case you're not familiar with programming, for each is a very like common way to say looping over each object. It's like a built-in thing to most programming languages. So now when this for each gets triggered for each of these objects, child objects, as if this UI foreground is meant to be a list, it will go through UI shelf, watering can holder, sun holder, soil holder, and it'll output them in this body. Now body just means that it's like a document, like the next is just what happens after, but the body is like this big chunk of code that you want to happen for each object. So if we take this scene object, we can just say set active. Set active. Or set visibility. Oh no, I'm sorry. I've been making games recently. set active. Uh, visible. How can I make it go faster? I think there's something that needs to be reset on my computer. Oh no. We'll just type in viz. Set visibility. There we go. Okay. So with this, you can see there's an input of a scene object. So for each object, it will trigger this while that scene object is set here. So for each, it'll do 4 times, it'll trigger this with a different scene object input. And so visibility on set to false with this empty checkbox, that means that all these objects will just turn off. So if I tap, you can see they'll all just turn off. And now you might wonder, why do they all turn off at once if it's going through each of them one at a time? And that's because it's going through each of them, but it's still all during one frame. So, but in between rendering the last frame and the next frame, it's doing all of this logic all at once. So there's never going to be a frame where it's rendering one missing and then the next missing. It's going to turn them all off at once because it happens super, super fast. So this is the type of thing that this subgraph is really, really, really reusable, because it's not doing a lot, but these things that it's doing are going to happen every time you iterate over a set of objects. So it's like not too much going on, but it's adding a get item from array, a for loop, and an array info, get children scene objects, get component by type, and start. It's like these pieces, I know how to make it from scratch, and I can do it pretty quickly, but it's one of those things that I was saying in the beginning of the presentation. It adds a little bit of friction if you have to remake that. So this is something that I knew as soon as I created it, I'm going to do this. You reuse this all the time. So I spent a little bit of extra time, maybe 20 minutes, maybe 30 minutes, just to make sure that it works for as many use cases as possible. For instance, using this get component by type rather than just hard coding the type. And yeah, this is one of my most used subgraphs in my personal projects. Okay, so I guess let's get to the last couple things. I like to show off this subgraph that I use sometimes called bool state.
This part is for which level do you think? Intermediate, advanced?
I think definitely it depends on your interests more than your skills. And I think you develop skills based on your interests. So it's like a feedback loop. It's like, if this kind of stuff interests you, then you'll naturally be inclined to check it out and use it and look into it. So even a very beginner, I think if you told them about this and they had a little bit of interest in making effects and visual scripting, even if they've never tried this visual scripting before, this would interest them enough that they would find a use for it, that kind of thing. So I think nothing that I'm saying requires you to be advanced. I think it's more about like how much you kind of want to get more into visual scripting. These are like kind of paths to go down rather than big things that you would learn. I think everybody kind of learns on their own path. So I'm just trying to set you down the right course.
Okay, thank you so much. But if you are a beginner and you're just trying this for the first time and you can't immediately understand everything, that is totally fine. I remember when I started my visual scripting journey, I was so intimidated, and the first couple projects that I've created has never ever used visual scripting. So just by starting on this journey, you're doing a phenomenal job. Just re-watch this video on your own time and go into the subgraphs, and you'll be able to understand how to read and understand the mechanics. But we have more courses coming up that will teach you how do you read a hard visual scripting project like this. So don't worry about it, and if you run into it, we'll help you debug and find your own project. So yeah, don't worry about it. But it is awesome to know like advanced skills like this exist, so when you do become a little more experienced, you can create something like this. So sometimes I even like to go to courses where I know I'm not going to understand anything, because one day it will make sense and it will click in my mind and I'll be like, whoa. But I think it's so much better than not knowing that it exists. So even if you don't get it on the first time, don't worry about it. We got you. Okay, going back to August.
Okay, so this is, yeah, thanks, Celine. I appreciate all that info. Very helpful. Um, I wanted to show off like one thing that's not very conventional, and to give you like some ideas of how kind of the bounds of visual scripting and making effects are kind of like up to you. It's there's a lot of weird, almost kind of hacky things that you can come up with that actually feel like they change how this visual scripting works. Even so, you have this face detection node, and it has this classic setup where it shows you when it begins detecting a face, and then it'll show you every single frame that it continues to detect a face. And then the end event will tell you when it has stopped detecting a face. And then none is just executed when there are no faces on the screen. It'll happen every frame. So you have a couple events that happen every single frame during a certain state, like when a face is there or when a face is not there. Then you have these one-time events like begin and end that just happen one time to tell you that something started happening or ended happening. Now, sometimes you want something like this to help control your logic as states of your effect change, as something in the effect changes. And so this is one of my favorite subgraphs that kind of allows you to transform something that you're monitoring and turn it into a set of events. So for instance, this takes in a state, and anytime this state changes, it will output these different events in the same exact way as face detection. Um, and I've named some of the events slightly differently to hopefully make them more clear, just because I personally didn't think that none was as clear as it could be. So I tried to name mine what I thought would be the most clear. So as an example, say that you want to know when at least two faces are on the screen. You actually don't care if there's only one face on the screen or no faces on the screen. You just want to know when there's two or more faces. So let's say greater than. Okay, greater than. And we'll just say greater than 1. So if there's only one person, we're going to treat our effect like, okay, our effect hasn't started. There's only one person. I wouldn't recommend doing that, by the way. I think you should probably, I think probably it's best to make effects work for one person. But if you have to do something else in your effect that happens, some grand, cool thing that happens only when two people have joined, then this is a cool way to do it using the bool state. All right, so when somebody leaves or enters, this is when the number of people on the screen change. If somebody enters the screen, the number of people on the screen goes up. If they leave, the number goes down. So
August,
then,
I think you have an effect like this where the two-person must get close distance wise to each other. I mean, emotionally as well, but distance wise, so that their heads would merge. I can try to find up a video, but in the screen right now, if me and August like lean together, like I have an aura and August has an aura, and if we like approach each other in the distance, then our auras will merge and it will change color. So that's what August means when like a two-person effect. One-person effect is something that you can just try out on by yourself, and two-person effect is like something where if there's two different person and you guys like interact in some way, then it does something else. So just an FYI.
and if you can figure out how to appeal to like couples or, people with kids, they'll often shoot videos with like multiple people in the screen.
Yeah, I think
So
I've actually seen a really viral effect where one person was like half the heart, and then the other person was another half the heart, and then only when you guys like stand next to each other, then the heart will like merge and like it will explode or something. And I was like, wow, that's a really nifty, fun effect. That would have killed it on Valentine's Day. Mm-hmm.
Okay, so in this case, when you're counting how many faces there are, you just want to reevaluate every time there somebody enters or leaves, like how many people are on the screen. So then you're checking if it's greater than one, so it's at least two people, then this will be true. And so the default is going to be false because before the effect starts, nobody's on the screen. So then now this should give an event only when there are two people. So let's just do something unhinged to signify when there's two people, like turn the camera off. So let's just say, oh,
Are we
another,
trying to say no couples, please? We're gonna turn off your camera if more than two people appear on the screen.
oh yeah, oh yeah, we don't want to see that. Oh no. Yeah, I definitely need to reboot my computer after this stream. Something's getting slowed down. All right, set visibility. We'll click this. Okay, so so when there are two people, we'll turn it off, and we're just gonna do the whole camera. If you turn off the camera in a TikTok effect, it will just basically be the same thing as turning all of the things off, except even less stuff will be running. Okay, so, and then if we want, we can duplicate this and say, okay, when there are less than two people, we'll turn the camera back on. And you can test this. Well, here, let me just test it with a picture. I just have this picture of my
August, I
friend.
thought August was just gonna go off the frame and like pop out with a friend, like, hey, this is a friend that I conveniently stash away for demonstration purposes. They can only come out when we're doing demos.
Okay. Let's just refresh. Does it recognize this as two faces? It thinks there's only one face. Maybe it's the reflection. Okay. I think it's the reflection. Well, I wonder if it recognizes this cat as a face. Sometimes it does. Okay. Well, then, I guess I'll ask one of my friends. I don't have any friends. No, I'm just kidding. Okay. Well, we'll give up on the live cam. We'll do one of these previews. The only thing with the preview is once the effect starts, you can't change if there's one or two people, but that's fine. Okay, you can see when two people enter, this greater than is 2, and it's not, the cool thing about this is it's not executing on update. So you don't have some logic happening every frame. So that's why I like this subgraph so much, because it just happens one time when some event happens, it updates, and then it doesn't take up any extra processing power to think about how many people are currently on the screen. That's might be what this one's doing, but yeah, so that's pretty nice. And then, if one of these people were to walk off screen in this preview, we would get everything turned back on. So yeah, something like this is a little weird. It's not just converting some numbers, doing some math. It's not just doing some work in the background. It's kind of taking this concept of a Boolean value of is the state of something true or false, and it's outputting a series of executing events. So it's almost like it's taking this data and turning it into doing something and like work. So it's really cool to see like some subgraphs can not only like convert the information they're taking in, but they can convert like the actual thing that they're doing. They're not just processing data, they're like executing now. So like this kind of thing, you can kind of think outside of the box of how subgraphs could help you do bigger and cooler things by just not having to remake it every single time, and help you think about like, now I think about projects as if this is a built-in node. It's almost like I've expanded the built-in capabilities of Effect House every time I create a reusable subgraph. So that's why I like making them, and I feel like they're very valuable, and it's fun. It feels good to make something you know that you're going to reuse. Maybe we can open up that project that we talked about with the two heads, and I can just show one of my personal projects, how crazy they get and how much subgraphs are helpful.
Ooh.
And that might be like the last thing to show off today.
Okay.
We're not going to save this. All right.
Guys, while August is loading up his project, I will tell you guys the mission or the little quest for this session so you can count your participation in the crash course. It is to make your own subgraph and show us a little screenshot and explain what it does. And if you're a beginner and you have no idea how to make a subgraph, that is totally fine. For you guys, you can take an existing subgraph like the Ogle counter or the randomizer 2D thing that we showed you today, and just like explain what this subgraph is. I think this exercise will help you guys understand like, oh, like identify this subgraph is built for this purposes. But while August was thankfully and very helpfully creating lots of fun projects on screen, I was also off to the side making my own project. So I will share with you my very last minute project. But guys, look at this. Ha 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 ha! Guys, what do you think? Do you guys like this? It is, let me show you guys. Just making sure there's no echo here. Okay, in this case, look, this I named is Soul Bunny Maker. So it's going to show you which bunny is your soulmate. And what you do is if you click on the screen, ta-da! It gives you a random bunny with a heart background. And it's so funny. If you go into these subgraphs, which look real professional, like the bunny matcher, appear and disappear, it's actually two interactions hidden in one subgraph. It's kind of like two cats stacked on top of each other and wearing a trench coat and saying, hey, look, I'm definitely a person. But this is, if you're a beginner, you can definitely go for something like this where you combine a bunch of the subgraphs to make your own. But here, now I've set this to appear and disappear because I want the background to pop up when you've tapped on the screen but go away after 10 seconds. So what I've selected is tap on the screen to hide and show object, and tap on the screen to delay, show, and hide object. What I did is I just selected this thing, and if you go under add interactions, you can add all of these amazing interactions. But I wanted it to specifically appear and disappear, and I couldn't find that in the interactions. So by combining those two mini subgraphs, I created my appear and disappear. And now to test that this is a subgraph and it also works on different things, I'm going to go to the asset library and I'm going to select anything that I want to make appear and disappear. Oops, it's loading here. And let's say that I want, this is where I got my bunnies too. Let's say I want to have a face sticker. Oh, because we're a bunny, we can totally put a bunny ear. I'm going to add this, and now you can see that it is applied. I'm going to go to the bunny ear section and make it bigger and put it on this person's head. Perfect. And then now I want this to appear and disappear with the click, you know? So I'm going to go over here and drag and drop this bunny sequence. And now I'm going to drag and drop. I just copy and pasted the subgraph, and let's see if it's working. To check if it's working, I have to turn this off to make sure. Ta-da! Now the ear is appearing and disappearing. Look, I made my subgraph just like that. It doesn't have to be hard. So your mission for today is go to our forums, which can be on community.effecthouse.forums, or if you're on our website, you can also, I'll show you guys. Here. TikTok, effecthouse.com. And then, oops, if you go to the community section, you can see that there is another forum for Crash Course Visual Scripting. And today's date is Subgraph Secrets. So go over here, take a screenshot of your new subgraph. In this case, I am going to put the appear and disappear and explain what the subgraph does. It's as easy as that, and that's how you can count to your attendance. Okay, going back to August and his wonderful projects.
Hey, nice. So I guess we can take a look at this project. Just to give you an idea, like most of the stuff that you've seen of mine, you would see in a template, which is, we have like very structured kind of internal rules of how it should look. And it's not like this, what you're seeing here. So this is what my own personal projects sometimes look like. And you can see there are definitely subgraphs. And now that we have subgraph instances, I think like some of these where I have a red blob and a blue blob are really, that would be so useful to have the instances where I would just edit one. Because I remember during this project, I was manually copying so many things between one to the other, and just like completely deleting and recopying them over. And so now I'm so psyched about that for projects like this. You can see there's a lot of stuff that's not in subgraphs, and that's because I think everybody has their own personal style of how they arrange things. And it's almost like this is a reflection of how your brain works. Looking at somebody's subgraphs might give you like a pretty good insight into how they kind of think about things. So I just want to encourage you to do whatever works for you. And that being said, that doesn't mean just like don't try to like improve, but just like notice like what are the things that slow you down, or like when you create things, what are the things that are most valuable to you? Like try to just have some like really good awareness about your visual scripting, and that way you can improve the things that matter most. As you can see for me, I left a lot of this just kind of out in the open because I felt like all these things on the top level are just things that I want quick access to. So that's another thing. If you're not making a template, you can organize things like this, where it's like when I open the project, the things that I'll be editing are going to be on the top level like this. I don't want to pack these away into a subgraph just because they look neat and tidy. If I'm the only one looking at this, then this looks neat and tidy to me. So I just wanted to share that with you because like some of these things, I mean, it's funny because like this one is still just called subgraph 1. So maybe that's like not a very good practice. But since I can see mouth open a mouth, I immediately remember what this subgraph is and what it does. So like we've got all these different things just doing a small bit. And that's because they each might be reused. For instance, inner lip distance. This is taking the face points from the face info node, and I'm taking 0.102 and 98, and those are the center of the mouth, and they're the inside point of the lip on the screen that we're tracking. And as you can see, it's a normalized value between 0 and 1. So, I thought I'm definitely probably going to use this before to get distances between different points of the mouth, but I don't want to look up these numbers. So I hard code them into this thing called inner lip distance. This is the type of thing where I don't want these values exposed because they're not like human readable values. There's something I have to look up on the internet. So if I'm going to look it up on the internet, I'm probably just going to hard code it into some more things where I have like full mouth height, inner lip distance, these things that I might find a use for in the future. So I hope that's useful to kind of see some of the things that I do. And I hope it's reassuring to see that, like, hey, even though I'm the guy who makes the templates, my own personal stuff isn't 100% clean and organized. You can make really fun, interesting, and engaging stuff while it still looks like this on the inside. The most important thing is that it makes sense to you. So I hope this helps you find your style a little bit and encourages you to improve in whatever ways are the most important to you. And yeah, good luck with your visual scripting journey.
Thank you so much, August, for that wonderful presentations and teachings. I feel like we learned so much. A great comment from Heather McGee. She's saying that can we share the subgraph as well if we want? I think she's talking about the forum. Yes, please feel free to share the subgraphs that you created. On the Wednesday live session, before we start, we are going to go over the subgraph submissions. I'm going to choose a couple of my favorites and show it on the live. So definitely go and show off your amazing subgraphs. We want to see what you've created. And maybe we'll see the Heather counter is the next Augo counter. A lot of people would be using your subgraphs, and I think that is so fantastic. Okay. The verdict is in. The poll for favorite subgraph. Number 1 is Augo Counter with 44%. Next one is Touch Drag and Drop with 33%. The third one is Random Number Supreme. I'm kind of sad because I love the Random Number Supreme, but I guess it could be replaced by Random Index Generator. Index Generator, but maybe. And lastly was the for loop automator. So I don't know how you guys feel about this result. Let us know in the comments. But thank you so much, everyone, for attending the session. I know there were some technical difficulties, so we'll upload the edited version with no technical difficulties on our channel, so you guys can go watch that through. But thank you so much, everyone, for attending. It was a pleasure talking with you guys, seeing your reactions, and I hope to see you all on Wednesday. Any final departing words, August? Okay, sounds good. Bye, everyone. Have a wonderful rest of your day. See you again on Wednesday with Melody, so definitely attend. Bye, guys.